So some of this it should be very familiar to you. I mean, you've had the Pythagorean Theorem at least since 8th grade, if not before. So let's not play with the calculators. All right. So look at this first part, your review. If you were to square 9, what would you get? 81. If you were to take the square root of 9, what would you get?
3.
What? Oh, that's weird. We would get 3. And technically it's plus or minus 3, but unless you're, for right now, we'll just assume that it's a positive square root that we're taking. And then for the second part, if we have the fraction 1/4, if I square it, I have to square both the numerator and the denominator. So 1 squared is 1, and 4 squared is 16. So when you square fractions, you have to square both top and bottom. What is the square root of 1/4? Yeah, you want to take the square root of the numerator and the square root of the denominator. So the square root of 1 is 1, and the square root of 4 is 2. So none of that is terribly new. Then our new vocabulary word for the day is hypotenuse. And this is our hypotenuse right here. The hypotenuse is a side that is always across from a right angle. It is also the longest side in the right triangle. And so down here you might want to circle the longest side. It is vitally important that you recognize, if you're given 3 sides to a triangle, that you recognize which of those 3 sides is the hypotenuse, because it makes a difference when we get to Pythagorean's theorem. So I want you to write true or false. Number 3, the hypotenuse of a right triangle can be any one of the 3 sides. True or false? False. Why?
Because it can only be the opposite side of the right triangle.
It can only be the longest side, right? Number 4, one leg of the triangle at the right has a length of 9. Is that true? Is that a leg? Yes, so that's true. The hypotenuse of the triangle at the right has length 15. Is that true?
Yes.
Yes, how do you know? It's the longest side. All right, so then turn. We've got 2 theorems. It's really the Pythagorean Theorem that it says, whoops, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of hypotenuse, which is this right here. We have the converse of the theorem that says that the sum of the squares of the lengths of the 2 sides of a triangle are equal to the square of the length of the third side, then the triangle is a right triangle. So you can prove something's a right triangle if you can prove that the 2 smaller sides, if you square them and add them, equals the length of the third side squared. So that's how you prove something's a right triangle without knowing that it has a right angle. So I want you to look at number 6, use your calculator, and I want you to write here and here and here what 13 squared is, 5 squared, and 12 squared is. And quite frankly, you should know all of your perfect squares up through 15 squared. So you really shouldn't need a calculator for this. Do you know what 13 squared is? So it's 169, so I'd put 169 here. And then 5 squared, we all should know, is 25. What's 12 squared? 144. So I want you to add the 169 and the 25. It should be obvious that it's not going to add to a smaller number, 144, right? But what is 169 and 125 equal to?
194.
What is it?
194.
Okay, I'm going to trust you on that. 194. That does not equal the 144. So therefore, that doesn't prove that it's not a right triangle. What did they do wrong? Yeah, they didn't put the longest side where C is. I've actually lost all of my notes that I created. Oh, nope, there they are. So they didn't put the longest side where C is. If you look at the second equation here, we've got 5 and 12. Aren't those the 2 smaller? And that's the larger. So let's try it this time. So let's put the 25 above here, and the 144 here, and the 169 here. So what does 25 and 144 add to give you? So 169 does indeed add to give you 169. So this equation right here is the correct relationship among the lengths of the sides of that right triangle. And again, double check this last one, 144 and 169 are not going to add up to 25. What does 144 and 169 give you? What was it? 313? 313 does not equal 25. So number 7, a triangle with lengths 3, 4, and 5 is or is not a right triangle? So what's 3 squared? What's 4 squared? What do they add up to? 25. And what's 5 squared? 25. So they are equal, aren't they? So therefore, it is a right triangle because those values are equal. A triangle with sides 4, 5, and 6. I want you to decide that on your own. So what do you think? Is or is not a right triangle? So 16 and 4 squared is 16, 5 squared is 25. If you add those together, don't you get 41? Does 41 equal 6 squared, which is 36? No. So what do you say? It is not a right triangle because those are not equal values. So be really careful in this section. Don't zip through it. But notice that even though you're using a calculator, what are we showing? Our work. So if you are going to prove that something is or is not a right triangle, I have to see all of this, all of this, all of this, all 3 of those. I have to see the original problem, what happens when you square the numbers, and what happens when you add them together. I must see what does the left side look like versus the right side. And I must see an equals or a not equal sign. If you just leave me hanging and you just give me these 2 pieces right here, and you say yes or no, I'm going to count you wrong because you haven't proven it to me. So you're proving it. So make sure that that's shown in your work because I'll be looking for it. Okay, problem number 1. We're going to find the length of the hypotenuse. So the legs of a right triangle have lengths of 10 and 24. And so based upon the picture, our short leg here is 10 and our long leg is 24. So over to the left, they've started you with Pythagorean Theorem. We're going to substitute in for A and B. So we're going to substitute in the values 10 for A and 24 for B. So 10 squared you should know is 100. 24 squared probably don't know, so why don't you do it on your calculator. Tell me what you get. What'd you get? 576. And then adding the 100 to it is 676. So how do you find C? Take the square root. We're essentially taking the square root of both sides, right? We're taking the square root of this side and the square root of this side. Normally when we take the square root of both sides, we have to do plus or minus. But if C is a distance on a triangle, is it going to be negative? Is the distance going to be negative? No. So we're going to ignore the negative portion of taking the square root. And so what is the square root of 676? 26. Does that seem like a reasonable answer? Yes, why? You got it, Sam. It's longer than 10 or 14. If it's the hypotenuse, it has to be longer than any of the 2 sides that you use to add to get there. So it does seem reasonable. And so the length of the hypotenuse is 26 units, whatever that is. And the number 12 brings in something interesting. 1 Pythagorean triple. Have you heard the word Pythagorean triple before? All a Pythagorean triple is, and you saw it above, let's look above here. You saw a Pythagorean triple above here. Where'd it go? Oh, right here. You saw a Pythagorean triple here. See how we have 3, 4, and 5? Those are whole numbers. I don't say integers because integers includes the set of negatives, and so we can't have a negative length. So if you take the set of whole numbers, really the set of natural numbers, because whole numbers includes 0, doesn't it? Can't have 0. And if you find a group of 3 whole numbers that works in Pythagorean theorem, that's a triple. 3, 4, 5 is the smallest Pythagorean triple you can have, and it's the most popular. So if I gave you 3 and 4, you could immediately jump to 5 because it'll get to the point where we've used it so much that you already know that the hypotenuse is 5 because it's that Pythagorean triple that you've memorized. But look at this one here, the 4, 5, and 6. It's got the 4 and 5, but the 6 didn't make a Pythagorean triple, so those are not a triple. Fraction ones don't count. So let's look back down here. One Pythagorean triple is 5, 12, and 13. This is another very popular one. If you take 5 squared, what do you get? 25. 12 squared, 24, and 13 squared, 169. What's 25 and 144? 169. Doesn't that equal the square of that, which is 169? So it works. Example 12 is saying, or question 12, if you multiply each number by 2, the 5, the 12, and the 13, what numbers are resulting? What do you get? 10, 24, and 26. Compare that to the lengths of the triangle above. How do they compare? (10, 24, and 26. How do they compare? They're identical, aren't they? So, so I would write here, these are the sides, the identical lengths of the sides of the above right triangle. And then I want you to put in here that they are a multiple of the base or basic Pythagorean, short for Pythagorean, triple of 5, 12, 13. Why didn't you write that down, Ivan? If I'm writing it down, you should be writing it down. I find it important, so should you. And they're going to give you here on the next page a definition of a Pythagorean triple. Should have given it to you before this, but they didn't. All right, so turn your page once you're done writing that down. And then we're going to look at problem 3. Can I turn this? Nobody has an issue? Okay. Page problem number 3, we're going to find distance. So the size of a computer monitor is the length of the diagonal. Anytime you buy a computer or a television and they tell you it's a 42-inch TV, they're calculating the length or the size of that TV by the diagonal of its rectangular shape. Why do you think they do that? Makes it seem bigger. For the longest time when I was, your age less, it didn't occur to me that if I went to buy at that time, let's see, you might have had a 24-inch TV was a big TV. So if I bought a 24-inch TV, I would have perhaps measured a 24-inch spot, maybe if I haven't had an armoire to put it in, and realized that, wow, there's a lot of extra space in here. I could have bought a bigger TV. I measured it. It was 24 inches. They cheated me. Well, then, and then you have to go back to the store and be embarrassed because they're like, oh, well, that's on the diagonal. So that was the marketer's way of making you think you have a bigger TV. So if you want to buy a 19-inch monitor that has a height of 11 inches, the 19 inches goes here, right? And the 11 inches is your height. It goes here. And it says, what is the width of the monitor? Because perhaps you have a particular space that you want to put it in. You want to make sure that it's going to be the right spot. So you can call this A or B. If you look at the information on the left, they're wanting you to call it B, because we're going to go ahead and input at the left. Oh, we're going to give reasons. So look at what they did. So what is this called? So there's our reason. Whoops, I'm losing my... Then what did they do from here to here? They substituted. So this would be substitution. Property of equality. Then what did they do from here to here? They squared it. So we'll call that simplify. So, oops, hold that thought. So they simplified. And then what are they doing from here to here? So normally they don't show this in a proof. You wouldn't see the subtraction, and I don't like how they subtracted it. So you can just cross that part out, and you can show the subtraction as minus 121 and minus 121. I like you to subtract below. And so this is the subtraction property of equality. And then from here to here, what'd they do? They simplified. And again, they usually don't show this step. You usually go from this step to this step, and you would have said the subtraction property of equality here. But because of the way that they wrote it, it looks like this. So we're simplifying again. And then what happened from here to here? Square root. And then what do you think they did from here to here? They simplified it where they used a calculator. So you might want to put simplify with a calculator. And so to the nearest tenth of an inch, how many decimal places is the nearest tenth? 1. 10 has 1 0, so it's one place. So that means that we are rounding to where the 4 is. Look at what's next door. Does the 4 stay a 4 with that 9 next door, or does it bump up to a 5? So it bumps up to a 5. So we have 15.5 5 inches. So I want to make sure that the space that my monitor is going into can accommodate a 15.5 inch wide monitor. Yes?
So it's going to ask us to solve for a specific variable. Do you want us to use approximate, like the wiggle?
If I'm asking the question, I'll be really specific about what I want. So I always like the exact answer. So if we were going to take this right here and give me the exact answer, let's go ahead and simplify it off here to the side. So let's take the square root of 240, and we're going to prime factor it. So what numbers divide into 240? So 24 and 10 would be a smart one to start with. And then 24, you can do 3 and 8, 4 and 6, 2 and 12. I choose 4 and 6. And so then I get 2 and 2, 2 and 3, and then the 10 is 2 and 5. So can't I make a pair of 2's and another pair of 2's, and then I have a 3 and a 5 left over? So what is 2 times 2? So we get 4 radical, and then what's 3 times 5? 15. So the exact width would have been 4 rad 15. If I ask for the exact answer, that's what I want. If I want an estimated answer, I'll tell you to round to so many decimal places. So just pay attention to the directions. And your book will sometimes do one versus the other. All right, any other questions on 3? Easy enough, right? All right, so look at 4. A triangle has side lengths 16, 48, and 50. Is the triangle a right triangle, and explain? So you need to circle the equation you will use to determine whether the triangle is a right triangle. So we're going to use Pythagorean Theorem. So which of the 3 below is correct? The first, the second, or the third? Does everybody agree that it's the first? Yes or no? Well, which is the longest side out of the 16, the 48, and the 50? The 50. So you always want to identify that longest side because this is C, which is the hypotenuse. It doesn't matter which is A and B, but it really matters which is C. And so that has to go on one side by itself, which you see here in problem number 1. This one has 48 and this one has 16 on one side by itself, and so those can't possibly work. And so this is the one that we're looking for. And so I want you to simplify everything and prove and determine, is it a right triangle or not? So you're going to start here with the 16 squared plus the 48 squared equals the 50 squared. So use your calculator and write down step by step and decide, is it a right triangle or not? So I gave you a calculator, you use it. Don't rely on somebody else to do your work. And then I want you to share with those around you to see if you agree or disagree with them as far as whether it's a right triangle or not. So chit chat amongst yourselves. Talk, talk, talk. Ivan talked to somebody. Danny talked to somebody. Tori talked to somebody. Jessica talked to somebody. All right, what's our conclusion? Yay or nay? No? Why? What did the left side equal? And what did the right side equal? Okay, so if you're missing this last row right here, this last line, you're going to be marked wrong because this is part of your proof as to whether or not it is. Because otherwise you could just say yes or no, and it's a 50-50 chance of getting that question right. You have to prove it by showing your work. And so in addition to this, I want to see a slash to that equal sign because they are not equal. And so therefore your answer is no, it is not a right triangle. And then number 18, the equation is false, so the triangle is not a right triangle. And then as I promised you, here is your Pythagorean Triple definition. It is a set of non-zero whole numbers, a, b, and c, that satisfy the Pythagorean Theorem. So notice that they used in that definition non-zero whole numbers. That takes away the one whole number that is 0. And then if you take any Pythagorean triple and multiply every number in that Pythagorean triple by the same number, in other words a multiple, then you create new Pythagorean triples. So for instance, if we just started with 3, 4, 5, what's another Pythagorean triple off of that one?
6, 8.
Yeah, multiply everything by 2, so 6, 8, and 10. What's another one off of that one? 12, where's he getting 12 from? 16 and 20. What did he multiply everything by? From 3 to 12? Oh, I see what you did. So he multiplied the 6 by 2 and the 8 by 2 and the 10 by 2, but technically we're multiplying the original triple by 4, and 4 by 4 and 5 by 4, right? So you could multiply that original triple by 3 and get another one, so don't miss out on anything. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. So if you see 3 side lengths that all have a common factor, so you'll notice that all of these have a common factor of 3, and if you reduce them down to this 3, 4, 5 that you recognize as a Pythagorean triple, you don't have to run through the Pythagorean Theorem. It saves you time and effort. You can just go, oh, You know, if you knew these two sides and they were the legs, and you go, oh, they have a 3 in common, divide them both by 3, I get a 3 and a 4, that means the fifth side must be 5 times that 3, oh, is 15. So you can get around the Pythagorean theorem by knowing your triples. Not every right triangle is a Pythagorean triple, though. Okay? All right, last page. So last page has theorem 8.3 and 8.4, the Pythagorean inequality theorems. It's an interesting theorem. And the first one says, right here, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So I'm going to write over here to the side what they just said. If the length of the longest side, which is the longest side, A, B, or C? So they're saying if C, whoops, let's try that again. They're saying if C squared is greater than A squared plus B squared, then your triangle is obtuse. Versus this one here, it says if the square of the length of the longest side is less than, so if C squared is less than A squared plus B squared, the sum of the squares of the lengths of the other two sides, then the triangle is acute. So I can tell, and this is any triangle, by the way, any triangle. It's not just a right triangle, it's any triangle. So we're using a right triangle theorem and applying it to triangles that are not right triangles. So that's important for you to realize that it's any triangle. And so in example 19, or question 19, in triangle ABC, if C squared is greater than A squared plus B squared, then your triangle is what? Obtuse. And if it is less than, it is acute. Notice that they used S, R, and T this time. And you can see on here, well, you'd have to know what the side lengths are, but the implication is that S is the longest side, so this would be acute. So then I want you to do the lesson check on your own. And they kind of walk you through it, 21, 22, and 23, so I'll give you 2 minutes to complete that. A triangle has side lengths 16, 34, and 30. Your friend says it is not a right triangle. Look at your friend's work and describe the error. So your friend has an error. So you find it. Work. I want you to talk about what you said, that how you described your friend's error. I want you to talk about it with those around you. So this is what I wrote. Your friend used 30 as the longest side instead of 34, and you do need to be wary of this. The last textbook we had always wrote these in order from smallest to largest, which drove me nuts, because not everything in life is fully ordered nicely for you. And so you can see that this one is not ordered from smallest to largest, and so you cannot fall into the trap of that third number always being the largest side. And so that's what his friend did, fell into that trap and used 30 over here. And so he should have used this. They did not ask you to run through and determine if it was a right triangle. But if you did, what is 16 squared? What is it? So 256 plus, what's 30 squared? What's 3 times 3? 9, and then 2 zeros, so you can do that without a calculator. And then what's 34 squared? 1156. Please add for me 900 and 256. Bless you. Does that equal 1156? Okay, so this is a right triangle, is it not? And that's what his work should have looked like above.